Okay, it's time. Uh, Good morning, everyone. This is a continuous process. Last Tuesday itself, we started the international series one with the topic title one as nanotechnology. Now, this week, uh, we are on topic two, that is about deep learning fundamentals and applications. And we got a good speaker, Dr. Kumar SS, Associate Professor and Head of the Department of Electronics and Instrumentation Engineering from Noorul Center for Higher Education. On behalf of the participants and our Nichi group, as well as on behalf of Gambella University, I welcome our speaker to present his lecture. Kumar sir, it's over to you.
Thank you, sir. Thank you so much. Yeah, sure. One second. Screen is visible?
Yes, sir, it's visible.
Okay, fine. Thank you. All right. Okay, first of all, I take this opportunity to thank Dr. Lalu, Director of International Affairs, NISH, as well as the management from Gambella University, Ethiopia, for giving me an opportunity to take part in this international lecture series. So the topic what we'll be looking into today is deep learning, its fundamentals, as well as applications. So what is deep learning? So it is a type of artificial intelligence technique where computers try to learn or understand, analyze data by recognizing the patterns present in the data. It is something similar to how the human brain works. Deep learning is a subset of machine learning. So there is a major difference between machine learning and deep learning. Is in the case of machine learning, the features need to be extracted by a different algorithm, whereas in deep learning, it itself will be extracting the features and it can do whatever the thing which we request it to do. So when we look into things, so if I ask you what is this, I think every one of us would be able to answer this is an apple. And if I ask you to draw or paint an apple, still we will be able to draw or paint an apple. So how is this possible? So this is because we have been trained or we have learned by some means what an apple looks like or how to draw an apple. So right from where did this training come from? So if you see it, right from when we were kids, our parents or maybe our teachers or friends, relatives, somebody might have taught us how an apple looks like. So I think it is the first thing most of us would be studying Maybe our parents or teachers might have shown a picture of an apple in a chart or maybe a textbook and said A for apple. So we know how an apple looks like. Maybe they might have shown us real apples also. So somehow, without knowing, we have learned how an apple looks like. So the next time when our parents or maybe teachers or somebody shows a picture of an apple, we are able to easily recognize this is apple. So this happens because of neurons which is present in our brain. So a human brain has around 100 billion neurons. They doesn't simply be there. They have been interconnected together. So an interconnection of these brains is what helps us to see an object and to identify what exactly this information is. So when we go deeper into the structure of a neuron, so it has several components like a cell body, nucleus, dendrites, synapses, and an axon. So the cell body with the nucleus is the place where the entire processing takes place. So this dendrites is one which carries input maybe from different neurons or maybe from different other sources into the nucleus where the processing takes place. Once the processing is done, that information is carried out to other neurons or maybe to the decision maker through axon. So when different neurons are interconnected, there will be a junction between these neurons, and those junctions are called as synapses. A single neuron is not sufficient for making a recognition of something or taking a decision or something. So we may need a collection of neurons. So basically, in our brain, we have these neurons interconnected together. Say, for example, if I want to identify an object like what I was shown on the left side, an apple, what I do is I see it. When I see it, the information is formed in my retina, which is carried to my brain through my optic nerve. So my brain has several neurons, maybe say millions of neurons. Now these neurons, a group of neurons will be activated or will be excited on seeing a red color. You may have another set of neurons which may get excited on seeing an orange color. You may have another set of neurons which gets activated when it sees a circular shape, or maybe in that case even the texture material also. So when an apple is being shown, those neurons which get excited or which are more attracted towards the red color, they become high, their strength becomes high, and as a result, with the help of the collective strength, we get an output as it is an apple. So now we know how an object like an apple is being identified or how it is being recognized by a human brain. So we want this same technique to be brought into a computer so that the computer can identify objects, it can take decisions. If you give between different types of fruits, it will be able to classify what are the different fruits available. Maybe if you give a medical image, it will be able to classify whether it is diseased or non-diseased. If you give a tumor image, it will be able to identify whether it is a benign tumor or whether it is a malignant tumor. You give a text and ask it whether it is a spam text or not, it will be able to identify all those things. This is for a computer or for a software to do this. We need to create a separate type of neurons artificially, and that neurons are called as artificial neurons. So an artificial neuron will have the inputs, outputs, and everything similar to a biological neuron. So if you see in this particular figure, we have axons, which is the input from another neuron. We have dendrites, which is the input to this particular neuron. We have the cell body, which process the information which it gets through the dendrites. Then we have the output, that is axon, which carries this information to the next neurons. So what exact processing takes place here? So in the case of this particular artificial neuron, you could see different inputs like X0, X1, X2. So these are input features. So in the case of our apple, we have a red color is one important feature. Then we may have the shape as another important feature. Then we may have the texture of the apple as another important feature. So X0, X1, X2 represents these inputs. Now these inputs are given to the neuron where the processing takes place. So this the input alone cannot give us an output because there is a certain portion of red is present, a certain portion of circularity is present, a certain portion of smoothness or roughness is present. So what portion is available? That is dependent by this thing called as weights, and these weights are given here with the, denoted as W0, W1, and W2. So the processing that happens inside the neuron is simply said as weighted sum. So we multiply each input with its corresponding weight, then we add everything together, we get a signal strength. Now this strength has to be decided whether this can activate the immediate neuron or whether it can give an output that is sufficient for the next neuron to do something. So for that, we use a function called as activation functions. So depending upon the strength which we get from the weighted sum of inputs, the activation function decides if it has to give an output correctly, whether it has to fire the next neuron. If the strength is less than the threshold which has been used inside the activation function, then we may not get an output in this neuron. So now this is an example of a simple or single artificial. But 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 in real cases, we might have several neurons connected together. So that is what is called as artificial neural network. So this artificial neural network is one which is shown in the figure. It has several layers. One is input layer, hidden layer. Next, the last one is called an output layer. So those neurons which are shown in yellow color, they don't do any processing. They are just to get the input from different sources. Maybe in our example of Apple, the information comes from our eye through the optic nerve to the brain. So we get those informations, maybe different input features. They get the information. There is only a functionality of this yellow neurons. Then they give this to the next set of neurons that is shown in the blue color, which is present inside the hidden layer. The actual processing takes place in this hidden layer. So processing goes on in this hidden layer and we arrive at an output, and that output is given to an output neuron. From there, output neuron will be telling whether it is an apple, whether it is an orange, whether it is diseased, whether it is non-diseased, whether it is having some problem with the image, something like that. And if you look closer, from the yellow neuron, you could see green lines connecting towards all the blue neurons. Similarly, from the second yellow neuron, you could see blue lines connecting to all the neurons present in the hidden layer. Now, these are called as edges. So, for example, the processing that happens in the first blue neuron is the input x1 multiplied by w11 plus the input x2 multiplied by the uh, weight present in the edge blue, that there would be w21 plus x3 into w31. So now we got the weighted sum of inputs. Now this will be applied to an activation function. Based on the output of the activation function, we give it to the output neuron where the decision is being taking place. So now this entire process, moving from left to right, is called as feed forward propagation. We say it as feed forward because we go in the forward direction. So we can say it as feed forward propagation. Once the propagation is over, we arrive at an output at the output neuron. Now this output can be called as predicted output, or maybe we can say the calculated output. Already we have an output which we want to achieve. That output can be said as target output. So this predicted output will be compared with the target output. And if we find an error, if both are not equal or if the error is high, then we do a process such a way that we have to adjust the weights. So this process is called as back propagations. What we do here is, from the output neuron, we calculate the derivative of error with respect to weights and we pass it to the blue neurons, from the blue neurons to the yellow neurons. Then we adjust the weights, W11, W12, W13, W14, all these weights will be adjusted. Again, we do this forward processing. We go back again, then we calculate the output, we get the predicted output, we compare it with the original output, we calculate the error. If the error is still available, then again we go for back propagation. So now this process goes on like this until we minimize the error. Once the error has been minimized, we can say that our network is being trained. So once the network is trained, when we give an input, the network will be able to easily identify. I'll just give another example. Say, for example, we students will be writing exams. So before writing exams, our teacher might teach us. They might train us with a particular subject. So here input is students and the output is the marks which we want to score. In most of the cases, the mark which we want would be 100 marks. So the student is being taught by a teacher, maybe by some other source, by some means, the student tries to learn. So So whatever he has learned, he has to write in an Excel. So the marks what he scored will be compared with our target mark. Our target mark is 100. Imagine the student got only 50 marks. So what we can identify from here is there is an error of some 50%. So we want to reduce this error. We cannot change the input because the student is fixed. We cannot change the output because our output is 100 marks. Only thing which we could change here is how he is learning, how is providing the weightage to the learning. Either you can ask him to write several times, or maybe you can ask him to go to a tutor, or we may give some other extra materials. Somehow we change the weightage of his learning. By changing this weightage of this learning, we make the student learn, and again we ask him to write the exam. Once he writes the exams, again we compare with our target score. And if he reaches around some 90 score, okay, it's fine, he has improved. Maybe again we can ask him to do add little more weightage. So this way, we make him learn until he gets 100 marks. So the same principle is what is being used in artificial neural network, where we give inputs, the weights have been initialized initially, the output comes with an output, then this output has been compared with our original output. If there is error is maximum, we adjust the weights in between until we get a good output. And once we get a perfect output, we say it is trained. Only when the network is trained perfectly, we'll be able to find out what we want it to do. So this is about the backpropagation and things. So what is then deep neural networks? So the difference between the previous network and this network, what I have shown here is, this network has several layers of hidden layers. So if you see in this particular, we have only one layer. Whereas here you could see it has different layers, layer 2, layer 3, layer 4, etc. So one advantage of having more layers is it can extract more features. Maybe the first layer can extract edges. The second layer can extract maybe color information. The third layer, hidden layer, can extract more of what you say, texture or shape or something. So this is one advantage from other machine learning techniques deep learning has. Because of this more number of hidden layers, it is able to extract features itself, or it is able to learn by itself and help us to get a better output. Since it has more hidden layers, or since the learning is so deep, it is called as deep learning or deep neural networks. There are different architectures available in deep learning. So the major architectures available are feed-forward neural networks, convolutional neural networks, generative adversarial neural networks, autoencoders, transformers, vision transformers. So a feed-forward neural network is what is being shown here. So this feed-forward neural network is sometimes also called as multi-layer perceptron. So this feed-forward neural network has input layer, a set of hidden layers, and an output layer. So one problem with this feed-forward neural network is, once when you're trying to recognize an image, or when you're trying to process an image, normally what happens here is, image is comprised of pixels. So each element of an image is called a pixel. So when we give an image to a feed-forward neural network, each neuron takes one pixel. So each pixel is given to one neuron. So imagine we have an image of 10 cross 10. So the resolution is 10 cross 10. So we have 10 pixels horizontally and 10 pixels vertically. So the total number of pixel elements present in the image would be 100. So for this case, we may require 100 neurons present in the input layer. If you have 100 neurons present in the input layer, then as is, the number of hidden layers or number of neurons in the hidden layers also gets increased. This is for a small image with a 10 cross 10 resolution. Imagine we have an image maybe about 1000 cross 1000 are the modern cameras which we use, maybe a mobile phone or maybe a digital SLRs or mirrorless cameras. They give us outputs with resolutions too high, maybe 1200 hertz or maybe 2200 hertz, sorry, 2200 pixels per direction, etc. So the size of the input neurons gets increased. As the size of input neurons gets increased, the number of neurons in the hidden layers get increased. This will be leading to a high computational complexity. So this can overcome by the next type of architecture which we will be seeing, that is called as convolutional neural networks. And one more thing, if you see, you could notice that at the output layer, we will be having 3 neurons. That is, one is red, one is orange, one is banana. In the previous case, we saw that it had only one neuron. The reason is the previous case was we want to just identify whether it is an apple or not. So it is binary classification problem. So binary classification means whether it is diseased or non-diseased, whether it is benign, whether it is malignant. It is apple or orange. So this is a binary classification. But whereas in this example, you could say we are trying to find out about three fruits, apple, orange, and banana. So it is a multi-class problem. So when we have multi-classes, depending upon the number of classes, we will be having the number of neurons present. So the pixels being given to the neurons and the processing takes place. So the next architecture which we would say is convolutional neural networks. So this is especially designed for structured grid data such as images. So they have convolutional layers, pooling layers, and fully connected layers. So if you see the fully connected layer at the last, it has only three layers: an input layer, hidden layer, and output layer. Whereas a feed-forward network, which we saw a little earlier, it has many hidden layers. So we give the input image. A convolution layer, what it does is it applies a filter over the input image, and it extracts features from this input image, and those features are called as feature maps. So once we get different convolution layers being applied to the input image, we get many number of feature maps. Again, the complexity is high. So in order to reduce the complexity, what Sir, we had network issues. Now it's okay.
Yes, now we are on, sir.
Okay, able to see the slide?
Yeah, it's visible.
Okay,
Yes,
fine.
yes, yes.
Okay, so it's generative adversarial networks. So this is which is commonly used in our editing apps, like which we use in our mobile phones for style transfer as well as other applications. So it basically has two networks. One is a generative network, and another one is a discriminative network. So the generator tries to generate or create synthetic images, which looks like the real image. So the discriminator, what it does is it compares this generated image with a real image, which we see at the top. um, and initially, they won't be the same. So what the discriminator tells is the image what you have generated is fake, and it gives that feedback to the generator. So the generator then tries again something, and it tries to create an image which is similar to what it has been trained on. So this process goes on until the discriminator gives us an output as real. So now this is an animation which shows how this happens. Generator creates a random noise, then it compares with the original image, then the discriminator says it is fake. It goes on until the generator creates an image which looks real-like. So if you are able to access internet, later you can just go to this particular site called "This Person Does Not Exist." If you enter into this site, you would be able to see different images being shown. Those people are not real. Those have been artificially generated by this GAN. Each time you refresh the website, you get a new image. They look so real to real images. Then we have another architecture called as autoencoders. This is mainly used for anomaly detection or maybe for image enhancement. It has two parts. The first part is called the encoder part, and the second part is called the decoder part. So the input image is given to the encoder, where it has been converted to another space called as latent space, where we minimize or we compress the input. So one advantage of this is from the structure what is shown in the center, you are able to identify it is an apple. From that apple, we can easily reconstruct an output image which would look similar to your input image. And this slide shows how it has been applied for denoising. So the first row shows original image, and the second row shows noisy image, and the last row shows how beautifully it is removing the noise present inside this. Transformers. So this is something which revolutionized like anything. So all the generative AI technology which we use today is because of this architecture that is called as transformer architecture. So the generative AI chatbots which we use like ChatGPT or Gemini, all these things has this transformer behind it. So basically this transformer has an encoder, decoder, some input pre-processing steps and some output post-processing. So what happens here is, say for example, I'm having a word. It is mainly used for natural language processing. So natural language processing means machine translation. You give a word in English and you want it to translate it to some other language, or you ask it to write a paragraph of something. So all these things are called as natural language processing. Say for example, I'm having a sentence like an apple a day keeps the doctor away. So how this sentence, I want to translate the sentence to some other language. So I'm giving this sentence as input to my encoder part. So in the encoder part, this will be divided into separate words. Like Anne will be separated, apple, a, day, keeps, the doctor, all these things will be separated. And to this separation, we will be assigning a particular numerical values. For example, Anne can have a value like 0.2, 0.4, 0.3, 0.5 something. Apple may have another value like 0.1, 0.35, minus 2, 0.54, 0.5, something like this. So we assign something. Now this process is called as tokenization. So tokenization is not sufficient. It also need to have the positional value because Apple is present in the second position and doctor is present at the seventh position. Again, we give different positional encoding also. Now, this particular thing is given to the encoder, where this encoder has a novel particular mechanism present that is called a self-attention mechanism. So if you see all the current architectures, maybe the recent architectures 324 developed architectures, they use this attention mechanism. What excel in this attention mechanism? We give more attention to the important parts. So the tokens which we have separated in the previous case will be looked for long range dependencies or the spatial relationships between these tokens. From there, we extract information which is given to the decoder. From the decoder, we would have converted this an apple a day keeps the doctor away to the original language which we wanted to be translated. So the success of this transformers in natural language processing was also brought into image, and those transformers are called as vision transformers. They use the same process what we have seen in the case of NLP, or the transformer which we have seen little earlier. Here the input is an image, so what they do is they divide the image into patches, and then the processing is similar. We encode it with some numerical values, we give the position encoding, give it to the transformer, then the transformer will be giving out a final output, whether it is apple, orange, a bird, car, or whatever it is. This is the example of it showing it. So we have the input image, which is divided into patches. It is being encoded, given to the transformer encoder, and finally we'll be getting an output. So these are some of the major architectures which are used in deep learning. Now we'll enter into the applications of deep learning. Like that, the major applications include computer vision, where image classification, we want to classify whether it is apple or orange, whether it is disease or non-disease. Object detection, you have a scene in front of you, you want to find out what are the objects present in that particular image or the scene, that is object detection. Facial recognition, the security feature, what you see in your mobile phones or your laptops, or maybe other security uh, systems, facial recognitions. And autonomous driving, I'll come to autonomous driving a little later. Then we have natural language processing, like what we have seen, machine translation, translating from one language to another language, question and answering. You ask chatbots, you ask it a question, it is going to respond. The chatbot will be answering very similar to how a human does this. Then we have language generation, which we might have used daily in the ChatGPT or Gemini. We ask it to write a paragraph of something, and it gives us the particular reason. That is what is called as language generation. Then we have speech recognition, synthesis, etc. So, for example, we have voice assistants in our mobile phones. Like if it is an Android phone, we have OK Google. If it is an Apple phone, we have OK Siri. If it is a Microsoft-based device, we have what is called as Cortana. So we simply say, "Hey Google," or "Hey Siri," "Okay Google," or Cortana, what is the weather today? So it is able to recognize our voice, and it is able to give us information we need. And again, it finds a greater application in healthcare, disease diagnosis. You give a certain set of history, a certain set of results which we get from some lab, and it is able to predict what disease it is or what is the stage of the disease. You give a medical image like CT image or MRI image or ultrasound image, it is able to exactly identify what is the problem there. If the object has a tumor or something, what stage is the tumor, whether it is benign or whether it is malignant, etc. Then it is also used in finance for detecting fraud. For you can, if you are investing in share or something, you can predict the market how it is going. In autonomous vehicles, it is used for object detection, path planning, decision making, etc. So the object detection means when the vehicle, autonomous car or vehicle is moving, it has to detect the objects in its surroundings. Only with this it can move forward. Path planning is there may be a path available. It has to perfectly choose the path through which the vehicle has to move. Decision making is when the vehicle is suddenly moving, immediately all of a sudden if a pedestrian is trying to cross, the two things has to happen. Either the vehicle has to stop or the vehicle has to slow down. So this can be done with the help of a decision-making process available with the help of deep learning. This deep learning is also finding tremendous use in robotics, where it is used for picking and placing objects, identifying objects, sorting out objects, and also for moving objects from one place. So today, if you see the major providers like Amazon, Flipkart, and maybe eBay, etc., they are using these robots to pick objects from the shelves and then even to deliver objects to the customer. I'll just focus on some applications, major applications. One major area where the deep learning finds its application is food industry. So you could see from this image, it is used for finding out how ripe the strawberry is. You could see there are a percentage of ripeness is also available. So the one at the extreme right shows 0%. The bigger one, which is red and beautiful, has 98.3%. So most probably, if I'm having an automated robot or something to pluck this fruits, only the thing which is having 98.3 ripeness would be plucked. So I'm able to find out to what extent it is been ripe, etc. Then this is a beautiful thing. We go to a hotel or a restaurant, we order a food, we want to find out what are the ingredients present here. How beautiful it is. The deep learning is able to identify each ingredient present it and tell me what is present here. That is a beautiful thing. It is used for food quality check. So at the left side, what you have is a picture of banana, apple, and orange. They are fresh. There is nothing wrong with this. Damaged, they are rotten or something. So it is able to easily differentiate between those two things, and it is telling us what exactly is the problem there. Then in the case of self-driving cars, the top picture tells us, it identifies the objects and it tells us what is the problem, who is going in which distance, etc. Whereas in the second thing, it is able to segment each objects. That is what is called as object segmentation. This process is called as semantic segmentation. So the cars in blue color, the pavement is in pink color, the road is in brown color, trees are in green color. So it is able to identify each things. And this is from an inside video from a uh, autonomous car, which is developed by Google called as Waymo. So how it is able to look the path and how it is able to move from one place to another. Then it is also being applied in areas where an industrial application, say for example, in the case of an PCB design, where exactly is the fault, because we are going to manufacture or develop electronic products. It depends upon this design. So this fault and other things present in this can be easily found out. It can also be used for finding out finding out the defects present in welding, defect present in some other, like we can say, like if it is having some vibration thing, hollows, or maybe the bonding is not perfect. So in all these cases, we can use this deep learning to find out, pinpoint the location where it is having defect, and also to identify what type of defect it is. And in medical application, it plays a major role. You can easily analyze each organs. You can analyze in depth of the tumor, or in depth of the particular organ, what is the volume of the organ, how much portion has been affected, where that particular treatment is needed. So all these things can be done with the help of deep learning. And even if you develop a deep learning based algorithm, and if you create it as an app, in real time, you can take a picture of the particular leaf or the plant, and you can identify what is the disease. Now, I think this is a leaf of a tobacco plant, and it has been taken, the picture has been taken with the help of a mobile phone, and this mobile phone will be telling us what type of disease this particular plant has, and it also can suggest us some pesticides, or maybe type of fertilizers, and what type of things has to be done to this. It is so beautiful. We have a drone which is able to pluck apples, and this drone has a deep learning algorithm put inside it. It is able to correctly identify the apples and look into whether it has been ripe or not, and then it is plucking it and it is bringing it. And then the major application of deep learning is generative AI. So something, it has revolutionized the world like anything. So generative AI is, with the help of deep learning, you are able to generate text, you are able to generate code, you are able to generate image, you are able to generate speech, videos, and even 3D models. You give a set of your floor planning, or 3D drawing, or AutoCAD drawing to this generative AI, and it will be giving you a 3D drawing about the architecture, how your room should look like, how the major car companies are using generative AI to optimize the spacing so that they can reduce the weight, or they can reduce the cost. So in the case of text generation, we might use these things. ChatGPT is one text generation. Gemini is another thing. I'm not going in depth about this because we all might have used this for some applications. Image generation, so beautiful. So what I have shown on the left side is the prompt, the input which you give the Gen AI to generate the image, like what you want is called as prompt. Whatever you give as input is called prompt. So the prompt, what I given here is, I want a giraffe, like I want to become a wildlife photographer, so I wanted a beautiful sun at the behind, and maybe a giraffe. So I asked it, I was specified which camera I want, and also I was specified which lens it wants. So with the help of this, I'm able to get this. Then we have This can also generate images. It can generate videos like what you see here. So you give a prompt, like I gave it a prompt like I want a video similar to Gladiator movie, and I got something similar to this. And we come to the end of this, and this is a thank you. And if you see closely, this image, what I've used here is also with the help of Gen. I gave it a prompt like I wanted to generate an image for giving a thank you for a presentation on deep learning, and I have used this Bing image creator and gave me an image, colorful image. I specified I wanted to be colorful, and it has given me this image. And so today we have looked into what is deep learning. We have seen about the basics or the fundamentals of deep learning, how it got its inspiration. Basically, it got its inspiration from biological neurons and the different architectures of deep learning. And we have also seen some major applications of deep learning. So, any queries?
It's a wonderful presentation. Mark,
Thank you so much, sir.
you have applied for that for your thank you. That's a wonderful thing. I know many of them raised their hand.
Thank you so much.
So, if any questions, you can ask for 2 minutes.
So, anybody has any questions, you can ask me.
Do you have a question?
Yeah, sure.
If you have question, raise your hand and you can ask. No question?
Look, Lalu sir,
Yes, sir, please come.
thank you so much, sir. We have no queries.
Okay, thank you so
We
much.
can, yeah, we can wind up, sir.
Sure,
Thank you
sure.
for
Okay.
your presentation.
Okay, thank you so much. Thanks for giving me an opportunity. Thank you, Lalu sir, and thank you.
Thank you very much for joining this session. If you need to contact Dr. Kumar SS, you can email him directly, and he will give his contact details in the chat box.
Also send the PPT also, sir.
Sure, sure. I'll send it. You can contact me in this email.
Yes, sir. Yes.
It's Kumar SS at niu.com. You can directly post your
Yes,
questions to
yes.
him. And he has given only the basic details of deep learning. If you need advanced things, then you can directly ask him. So I will get the PPT from him and I will post it to Mr. Jagan sir.
Okay.
Thank you.
Also, I request everyone to complete the feedback form so that we can improve ourselves for the next lectures. Thank you, Kumar sir. Thank you for your and thank you everyone. Let us wind up
Thank you,
this
sir.
Okay,
meeting.
thank you.
Thank you.
So
Thank you very much. Have a good day. Thank you. Thank you.
Possible there is a feedback.